Hello, everyone. I'm Chelsea from the StarRocks community, and I'm also a product manager at CelerData. And today, let me give you a sneak peek about StarRocks 4.0. So before we dive in, let me give you a quick introduction to StarRocks. So first off, StarRocks is a high-speed real-time analytics engine. So we can provide sub-second queries at scale with our own storage format. And we also have a very powerful execution engine that can let you perform a high-speed on-the-fly joins. So you don't have to denormalize all the data before you load them into StarRocks, right? That's really our bread and butter. And another big one is we can handle the real-time mutable data. So if your data come from Flink, Kafka, we can handle it even with the upserts and deletes. And if you look at the overall architecture here, it's super simple and is storage and compute separated. So scaling is really straightforward. And now if your data is lives in open lake, you don't have to move it around. We can directly query the lake with StarRocks. We already support all the common table and file formats out there. And from the performance side, we've got the MPP architecture and tons of SIMD optimizations. So you're getting the top tier performance by native. And on top of that, we have done a lot of Lakehouse specific work. Like we have a built-in caching system, we have a distributed metadata structure, and we even have a materials view acceleration layer. So put this all together, you can keep your lake as the single source of truth. And StarRocks can get you the data warehouse-like performance on the open data lake. So what's new in version 4? We are still pushing everything forward. Our vision is all about being fast everywhere, like fast data, fast queries, fast delivery, and even fast for agents. So first, the fast data. The name kind of speaks for itself. So the data need to be real time. But the thing is, in the real world, real time is never easy. When we talk with our customer, we always hearing the same complaints like real-time ingestion is too expensive. Yeah, the storage itself is very cheap, but the S3 API calls are killing our bills, and we just want our dashboard to be fresh. And yeah, that's the truth. If you want your data to be queryable in real time, it needs to land fast, right? And if you want to get a good performance, you got to do the necessary compactions, right? So you have to do all those API calls. So that sounds like a trade-off between the performance and the cost. But the reality is, if you really want this to work in your production environment, it's not just about the speed. You have to take consider of the stable, the cost efficiency, and everything. So that's exactly what we want to solve in version 4. We want to lower the cost while keeping the performance. So in version 4, we made an end-to-end push to cut the API cost down. We bundle files together, we utilize the meta to avoid hitting S3, we optimizing our compaction strategy. Yeah, we still keep it clean, but we are not going to overdo it. So we can save both the API cost and the compute cost. So put together, these changes make real-time ingestion way more cost efficient. And you can see from the chart here, the API costs dropped by 70 to 90% compared to the version 3.3. And here in the right, the ingestion latency and the query latency, it almost unchanged. And in some cases, even improved. So with version 4, fast data isn't just faster. It's about faster, more stable, and way more cheaper. And you'll get your real-time insights in a more cost-effective way. And still, we have the good performance. And the second fast is fast queries. Performance is always been the star of the show for us. And let's start from the foundations. Honestly, we never skip a single opportunity to make everything fast. And in version 4, as always, we continually to deeply optimize our most fundamental operators like the joins, the scans, the aggregations. That's like the building blocks of pretty much every query. So the result you see here, you can see from the TPCDS benchmark. We compare to version 3.3, like performance we got 1 year ago. Version 4 achieves like 1.6 times faster. And this isn't just for the StarRocks internal tables, right? It also applies to the external data lake tables because we optimize the fundamental operators. So in fact, you can see that the test benchmark is the result comes from the fully analyzed Iceberg tables. So wherever your data lives, StarRocks can make it faster. And now let's talk about the data type that always been tricky to optimize, the JSON. Yeah, JSON is everywhere these days. Like you have app logs, event streams, user profiles. Yeah, but the problem is querying JSON has always been slow and painful. Yeah, of course, JSON is very flexible and easy to use, but for databases, JSON is like a black box. It's heavy, it changes fast, so we cannot add a lot of optimizations directly on the data tab, right? So most systems will force you to flatten it first, which means you have to add a lot of heavy ETL before you load the data into the system, and you lose all the flexibility. And the flexibility is the point of using JSON in the first place, right? So actually, we introduced the flat JSON back to version 3.3. So that's actually automatically flattens the JSON for you. Basically, we can extract the common fields in the JSON during ingestion and stores them as a structured data type. But this is just a storage level optimizations. It's just a start. In version 4, we went a lot further. We add a bunch of execution level optimizations. So that's officially we make the JSON data type to the first class data type in StarRocks. The first class data type in StarRocks means like we can apply all the optimizations we do for the structured data type to the JSON data type. Like we can add indexes, like we can use the global dictionary for the low cardinality strings, and we can utilize like the lazy materialization, and we can do the predicate push downs and etc. So the results here are huge compared to version 3.5 when we already have the flat JSON enabled. We achieve 3 to 15 times faster with all the execution level optimizations. So that's really huge improvement. And the best part is you don't have to change your pipeline. You just load your JSON to StarRocks and query the JSON as always. Like you can still use all the JSON functions you like and query it as normal. And under hood, StarRocks will take care of all the acceleration, both from the storage side and the execution side, to get you the near columnar performance. So now we can finally do the real-time analytics on the JSON directly, whether it's log analytics or your monitoring system or your user behavior, we can do that. And next is the fast delivery. When we talk about the fast delivery, the idea is really simple. Yeah, we just want to let your query pipeline as short as possible. If we can query the lake directly with good performance, we will definitely do that. So actually, we've support query external tables since version 2, and over the years, we've done a bunch of query engine level optimizations. But the reality is the lake is messy. Most of the time, the lake is messy. So sometimes your data is right there, but it's not written for the query engine. So for query engine, sometimes it's impossible to build miracles on a messy lake. So the first step in version 4 is what we call for the Lakehouse-Native delivery. Yeah, because for StarRocks, we do have our own storage engine, right? We have our internal table. and we have years of the experience of the data warehouse. When you're using StarRocks internal table, we never let you to worry about the storage, right? Your data is just ingested and you can query it in very good performance. So in version 4, we are trying to migrate those experiences to the open format. For example, we can use the global shuffles to avoid small files. Like we can use the spill to get more efficient ingest. Like we can generate a more query optimized files with the local sort. Yeah, and we also give you a compaction API to manage all the files. So in short, we want your data length ready to query. It's just the right ones query ready. And then just the file level management isn't enough, right? As a query engine, we rely a lot on the metadata and the stats to generate better plans. But you know that when we speaking of the lake table are always huge and their metadata are always huge. And yeah, it's hard to get their stats, and any modification on the table may make those stats stale. So in version 4, we enhanced our strategy. So first, we already imagined the worst scenario, like there's no stats at all. And yeah, we will need to choose the most cost-effective way to grab the needed information to make the right assumption, right? And yeah, in this way, we can generate better plans. And also, we improved our performance on getting stats. And also for the metadata, we improved our metadata refresh strategy so we can get better freshness and also keep the performance good. So here you can see this is our query performance upgrade for the Lakehouse queries. So at the file level, the first level, we keep investing heavily to making sure that your data is ingest once and query ready, right? And on the query layer, yeah, we are always doing what we always do, like we continuous optimizing from the fresher stats to the smarter operators, to our native caching system, etc. We are making sure that you query directly on Lake can have the best performance. And on top of that, if you are talking about a scenario like high concurrency, low latency, we do have our materials views to give you the next gear. So all of this acceleration method, we are not adding any additional pipeline or breaking the single source of truth of your data lake. And finally, none of this matters without the security, right? So in version 4, we extended our access control with the JWT integration for Iceberg REST catalogs. And we also fully support for the vended credentials across AWS, GCP, Azure. So you're not just getting the speed, you are getting the speed with the enterprise-grade security. Yeah, and next is the open source. Yeah, open source is like our spirit. We are keep doing this, and in StarRocks version 4, the biggest story is still the community. And for years, users have been enjoying our shared data architecture. Yeah, everyone can use it, but it's hidden in a black box. Now we are taking a big step forward. Yeah, CelerData is opening the core foundation to the community. Now everyone can see it, can improve it, can extend it. So what exactly are we open sourcing? So the first one is a StarOS. StarOS has always been the backbone of StarRocks shared data architecture from the day one. It's already powered by more than 200 enterprises. Before you can use it with the binary package we shared in the community, right? But you can now see the code, and in the future we will fully open source the code. And the second is a new feature for the community, the multi-warehouse architecture. So the multi-warehouse is you can group several scenes together as a warehouse, and you can have multiple warehouses in one cluster. So the different cluster the different warehouses, they are physically isolated from each other. So this truly brings the enterprise-grade resource isolation. Yeah, you can split your workflows. Like you can have one warehouse for your queries, you have one warehouse for your data loading, and one warehouse for you like compaction jobs and materials view refreshing and etc. So those different warehouses, they won't interface with each other. So in this way, you can manage your cluster resources in a more business manner, and you can scale it easily too. You can either add more CN nodes in the one warehouse, or you can add more warehouses to your cluster. So in the past, this was only available in CelerData, and we will open source for the whole community in the future. Yeah, right now we are still getting everything ready for the open source, and you'll see it coming your way in the near future. And next is the roadmap. Yeah, last but not least, StarRocks 4 is just a start. And yeah, so here's a sneak peek at what's coming next. So first is the effortless real-time. We all know that keep things real-time is tough. You're always tuning data distribution. You need to fight with the data school just to squeeze out the performance you need. And then once the data is changed, you have got to rethink all the strategy. That's really hard to maintain, right? So here is our idea. We want to let this self-optimizing. So no more babysitting. You just send a query and let StarRocks to take care of the rest. We will try to give you the fresh data instantly accessible with best performance. And the next is Lakehouse-Native performance. Yeah, this has always been our focus. We'll keep pushing performance for large-scale Lakehouse workloads, and not just on the query side, but also we are bringing the StarRocks proven governance capabilities to Data Lake. So we'll let you to build a high-performance Lakehouse much easier with StarRocks. And yeah, now we are working on the incremental materials views. Yeah, we do have async MV in the past, let you pre-compute things for the high concurrency, low latency scenario, but you know the struggle is sometimes even partition level refresh can burn resources. So, but if you skip refresh, the MV will quickly go stale. So with incremental materials view, we are aiming for the sweet spot, the performance and the freshness at the same time. And then powered by AI, yeah, StarRocks can definitely use some AI magic. We are working on giving you smarter guidance for the cluster management, like the table creation, like analyzing your query profiles. Yeah, on top of that, we already have our own MCP in place, and we'll keep making it better. Yeah, and this is just it isn't just us alone. We are also working closely with other communities to push this forward together. And finally, fast for agents. Yeah, agents nowadays are putting new demands and challenges on database. And that's why we are going to boost our vector index performance, which is just the GA in the new version. And we're gonna enhance our hybrid search, and we're gonna introduce more data types to handle the large, complex data analytics. So yeah, overall, back to the topic, StarRocks 4.0 is all about delivering the real-time intelligence on the Lakehouse, giving the users and the agents sub-second analytics at scale. So yeah, thanks. That's pretty much what I have for today. And the version 4.0 RC version is released. It's just the RC version, but you can take a look at the official website. We have all the packages, we have the documents and release notes, everything. Yeah, you can take a look. Yeah, thank you all for listening.
Appreciate that, Chelsea. Thank you so much for the awesome presentation. So remember, there's a poll. So if you want to vote how you like the talk, so we can continuously improve as a community, right? Now I think we have 3 minutes to take some questions. So first question: what's the roadmap for Python UDF? It looks like it's been an experimental feature since 3.4. Still is for 4.0.
Yeah, for Python UDF, actually, we've tested the performance is really, because it's Python, so the performance is really not that desirable. But yeah, it's a very common used language. But actually, we recommend you to use the Java UDF instead, because we have tested the performance is way more faster than the Python UDF. So I actually we think that the aggregate of Python UDF functions is not production ready, and yeah, the performance is way too slow. So we really recommend you to use the Java UDF instead.
Thank you. Next question: has the partition scan filter been optimized when using files to access S3 Parquet files directly? Currently, when using wildcard and filter partition using where clause is too slow when you have a lot of partitions.
You have a
It's in the session Q&A.
I see. Yeah, that depends. Yeah, we do have a lot of optimizations on the predicate pushdown, and we will keep doing it. Like in the past, we deal with array functions to push down the predicate, and in the near future, we are designing a whole new architecture of the predicate pushdown to optimize this scenario. And I think part of this is also because of the metadata, right? And if you do have a lot of partitions in your single table, sometimes it can be slow. So that's kind of two parts of the optimization. One part is we optimize the metadata for the better performance, and the second part is we can push down the predicate to the execution. And yeah, that's definitely some of the optimization will include it in this version. But because the question is pretty ambiguous, so
thank you, Chelsea. I think we have time for that's all of the time we have. Also for the slides, yes, we'll share the slides later. There are two questions we weren't able to answer, so please post them in the StarRocks Summit Slack sub channel. So we're gonna take care of all of the remaining questions there. Thank you everyone for joining, and thank you so much, Chelsea, for this amazing presentation. And also remember to do your poll if you like the presentation. I really appreciate that. Thank you. See you guys again in the next one. Thank you. Appreciate that.